Hello everyone. So in today's video we are going to talk about the low level design of car rental system. Now whenever in interview or in a workplace we have been asked to design car rental system, we the first thing that we are going to ask is obviously about the functional requirements, right? So I have elucidated some of the functional requirements over here. The first one being the rider should be able to request a ride by providing the pickup and drop location. Second one will be the driver should be allocated based on different strategies. So whenever we are requesting for a ride, there can be different strategies via which the driver can get allocated. It can be based on nearest available driver, based on the rating based allocation of driver, and any other strategy if we want to elucidate, right? And then the third one will be the rider and driver should be able to start and end the trips. We have to determine what can be the various stages of trip, so we can talk about it later on. Fourth requirement is we should be able to calculate the pricing dynamically based on the pickup and the drop off location. And finally, the vehicle management system will be performing all its tasks based on assigning vehicles to the drivers, etc. So now, before starting to the coding directly, there are two main steps that we should follow. One is designing the entities, and then the designing the UML diagrams, right? So wherein we can determine what all classes we have to make, what all interface or abstract class we have to make, what should be the attributes and methods inside those classes, etc. Right? So why before designing the UML diagrams or the class level diagram, the basic thing that we have to keep in mind is the solid principle. Now if you want, I can make another video on the solid principle, but these are the basic solid principles that we have, wherein S stands for single responsibility principle, wherein the manager class for let's say for example we have three types of classes. One is the data level class for in order to store the models, then we have manager level class, and then we have the interface level or the strategy level class, let's say for example in this case, right? So when we are talking about S, which stands for single responsibility principle, here the manager class will deal with their own responsibility. What I mean by this particular line is I'll show you once we'll go through the UML level diagrams. Okay. Second one is open close principle. So O stands for open close principle, wherein this particular O states that it allows our diagram or our structure, code structure, should allow extensibility without modifying the core logic. Okay. So, and then L stands for Liskov substitution principle, wherein we follow a common interface so that the system can switch between them rather than dealing with the class itself. Okay. Then we have I, which stands for interface segregation principle. What we mean by this is we have to separate our code logic into interfaces, ensuring that the class only implement relevant methods of interface rather than depending on different class, which will lead to tight coupling. So our class should rather depend on interface rather than directly depending on the class. And finally, D stands for dependency inversion principle, which states that the high level module do not depend on low level implementation, but rather on abstraction. Okay, so this is basically the solid principle which we have. Now coming to the UML diagram. So before seeing the UML diagram that I have made, I want you to think about what are the models that we are going to deal with, what are the manager classes, and then what is the actual flow that we are going to follow when we are dealing with the car rental system. So, while going through all these requirements, we can say that the first class would definitely be uh, the driver class, okay? Because what all things does car rental system mean? What are the different components of that? First one would be the rider, because rider is going to request for a trip. Then we have driver, because we have to find the available drivers for a particular trip. As we are talking about it, we need to have a trip class as well, because trip will comprise of driver, riders, pickup location, drop off location, etc. Right? And as we are talking through this, we can create another location class which will say that okay, this is the longitude and latitude of the location, maybe be it of rider, driver, etc. And once all these are done, then I think for now these classes should be sufficient. If we want, we can make a class or of pricing, but I don't think that we need of for specifically a class for that, because it can be defined as an attribute of a particular driver or a trip, right? So this will be the class. Now the next thing that we can talk about is manager. When we are talking about manager, what are manager classes do you think should work for us? We need a rider manager which will deal with all the attributes and methods of rider. So we need one for rider manager. Similarly, we need a driver manager. And then we need, of course, a trip manager, which will take into account both the rider and driver manager, right? Because it will determine that, okay, what is the current driver, what will be allocated driver for that rider, and then how we are going to allocate the drivers and how we are going to calculate the price for that. Now, as we are talking about allocation of driver and calculating the pricing strategies, there can be multiple scenarios via which we can calculate price. Similarly, there can be multiple scenarios via which we can allocate the drivers. And since we want to avoid the low level or the tight coupling between our code structure, we would want to have a strategy manager basically. So what does a strategy manager do? Let's say we want to have one strategy manager for our the driver allocation, and another strategy manager for to calculate the price. Okay, now as we are talking about driver allocation, what are the different ways via which we can allocate the driver? One way for driver allocation can be based on nearest available driver. Then another can be, let's say, based on the rating of driver. Then what can be another situation which we can allocate the driver? Maybe least busy driver. So let's say for now we have these three, these are the three ways via which we can allocate the driver. Similarly, if we want to calculate the pricing, we can keep one as the fixed pricing for all the trips, but second way can be based on the rating of the driver. Okay, so based on that, these two scenarios, we can calculate the pricing itself. So now we want to segregate this particular logic from the class level, and that's why we'll be creating interface of driver allocation and calculate pricing strategy, and then we'll link it these three as the implementation of the interface, right? So I think for now it seems to be good, wherein we have defined the model class, we have the manager, and now we have strategies to allocate the driver and to calculate the price, right? So let's see the UML diagram now. So this will be our basic UML diagram, wherein we have a driver, a rider. The rider manager will be taking care of rider details. Similarly, driver manager will be taking care of driver details. Now, these two, rider and driver manager, will be withheld by trip manager. So trip manager will take care of the rider manager, driver manager, allocate the both of their details, and then finally it will interact with the trip. Now what does a trip constitute of? So if, as we'll see, a trip cannot exist without a rider and a driver, right? So when we are talking about trip, the basic attributes that we can have is a rider, we can have driver, we'll be having location. Okay, and then based on that, we'll be calculating the pricing as well. So these three will be taken care by the trip class. Now, once the trip manager will perform its task, we'll have, we don't want to define all of our strategies within the trip manager, right? And that's when we have decided to, where's that? Yeah, here it is. So that's why we have defined this strategies, right? So for our strategies, we have one for allocating the drivers. So this is for our driver allocation. the trip manager will take care of strategy, and in our strategy we have defined one strategy manager, which can be of two type in our case. One is driver allocation strategy, another one is the driver pricing strategy. Now when we are talking about pricing strategy, we can have rating based price or default price, and similarly when we are talking about the driver allocation strategy, will can allocate driver based on least busy, nearest driver, or the rating based driver. Now, there's a homework for you wherein you have to decide in this UML diagram which all components will have association link versus composition link, wherein we, for example, one thing of which I have said that trip cannot exist without driver and rider, right? So has a relationship. So basically you have to decide what all is or has a relationship exist within a UML diagram. Okay, sounds good. Now since we have defined the UML diagram, let's go and start the coding. So when we are talking about we can start with the main diagram to decide what all things we need. First, what we'll do is we'll define a driver. We are in our new driver will be defining, let's say, D1 as Rocky, and similarly we want to give this person as the rating of 4.5, and then we want to define location of Rocky, and there will give, let's say, some longitude, this, and maybe 21.34. Once we have defined the location at that point of time, we also wanted to define whether this particular driver is available or not, right? And similarly we'll define another driver, let's say driver D2. We'll define new driver. Here the ID will be D2, let's say like this, where we want to give the rating of 4.7. This particular driver name is Sam. We want to give 21.34 or maybe 43, and then this one as 33.21. okay, so both of these drivers are available for now. And after this we want to have a strategy manager, but before strategy manager, let's create a rider. So we'll have rider 1, wherein we'll be defining new rider, and similarly we want to have the ID of driver as a rider as R1. Let's say the name is Alex. After that we want to define a new location, the new location class, wherein the magnitude will be again 42.31 and 12.21. okay, and after this is done, I think that's it. And also, no, I think for rider this should be sufficient, right? Now we have the driver, so we want to create a list of drivers, and within the list of driver we want to allocate the available drivers, and here we want to assign both the so here we want to create a res.s list. We'll have driver and driver 2. Sounds good. Okay, and now once we'll allocate the available drivers, we have created the rider as well. The next step would be to define the allocation strategy. Okay, so the strategy manager, what will that be doing? So let's say for now we want to have, but before that let's go and define all these class. So for now we need driver class, we need rider class. Okay, so I'll be creating a new, oh wait, let me create a new project itself. Car rental project. Okay, so this is done. Okay, now this seems good to me. So what all things we need for now? Let me quickly set up the JDK. We want to allocate the array, so this I have defined. Let me go and create these class. So first we'll define a package for our data, and in our data class we'll create a class for rider. And when we are talking about rider, what all details or attributes you want to give it to a particular rider? So first thing would be definitely the string ID, then we have string name, then let's say we'll create a location of the class. Okay, and after that I want to create constructor for all these three, and once we create the constructors, then I want the next thing to be the getter. So I want the getter of all three. Okay, now I want to create a location class. So I'll be creating a location class, and what all things you want me to have within the location class? It's basically a private double latitude and private double longitude. Similarly, I'll be having constructor for both, and now I have rider. Okay, this seems good to me. Now the next thing would be creating a driver class. Now talking about driver, what all things a driver class should have? What do you think? So we'll have definitely an ID, we'll have string name, we'll have location. Now we also want to tell whether our driver is available or not. What else? We'll have the rating of driver. Let's say we'll have the rating. So I think these attribute should be fine for now. Okay, so let's create constructor again, and once we'll have the constructor, we also want to create getters. So oops, not this. So here we have the getters. Other than this, we also want to have trip class, right? Now what does a trip class should have? Since trip will consist of rider and driver in addition to all the attributes, so the basic thing would be, let me give it a string. After that I want rider class, I want driver class, I don't want fare for now, but I want the location, right? So I'll be having location of the class, and then again the location can be pickup location, and similarly the location can be drop off location. Okay, after that I want trip status of the class. Let's define the constructors. So once we are talking, I don't want to define the trip status construction, so I'll have these ones for now, and then I'll create an enum for my trip status. So let's define a trip status enum, and here the basic can be requested, then we'll have in progress trip, we'll have completed trip, and we can have cancel trip. Okay, So these can be the for now for trip status. Going back to the trip class, now we'll have all the trip status as well. And now let's define we have to define all the getters, right? So here are the getters, and I'll define toString as well for the same. Got it. So this is the trip class. I think this is all for data. If we need anything, we can go ahead and create it. But other than that, let's define the strategies now. So we'll have a strategy package, and inside strategy package, the first interface that we want to have is for driver allocation strategy. Now, talking about driver allocation strategy, what all things we can include for the driver allocation interface. So basically we want to have a allocated driver, since as a return type we want to have a driver at the end of allocation. So we'll have this, and we don't want to have drivers, but rather we'll have list of driver, and we'll import the class, and here we'll just say available drivers, and we want to give the location, pickup location. Okay, let's import this as well. So we want to allocate a driver wherein the return type would be driver, and since for now this only have one signature type, we can define this under an annotation singleton, right? But I'm skipping that for now. Now, what all class can implement driver allocation strategy interface? So first one can be, definitely we can talk about least or nearest driver. Let's start with that, okay, which will implements the driver allocation strategy. Now we want to implement the method of allocate. I'm sorry, let me okay, so this makes sense to me. And now here for now I'm not adding any logic, so I'll just give me available driver with the stream, and I want to filter maybe the driver is available, and then I want to find first, and if not I would want to return as null. Okay, so I'm just keeping the logic very simple for now. This is for nearest driver. Similarly, I want to have least busy driver, which will again implement the driver allocation strategy. I would want to implement the method again, and then here also for now I'm just using the same logic, but yeah, we can always add our own logic. And similarly we'll define the third allocation strategy, which was the rating based driver, which will again implement driver allocation strategy. It will implement the method and have the same logic. Sounds good to you? So this is basically, these are the three classes which is implementing the driver allocation strategy. Now I would want to have another interface which will talk about pricing strategy to me. And what can be the method, do you think, for the driver pricing strategy? So at the end of this we want to return a price, so we'll have the return type as double, and I would want to calculate the price, but the pricing calculation would be based on the pickup location, Then we would want to have a drop off location, and then we would want to pass a base price. Okay, so let me import this class. And then what all methods should implement the pricing strategy? So first one can be fixed pricing, wherein we would want to do nothing but will just return the base price. So let me override the methods, and here I would want to return the base price. Okay, another implementation of pricing strategy can be definitely a rating based pricing. Again, the logic which I'm keeping for now is just very simple. You can always play with it. You can determine the rating of the driver, and then based on that you can return the price that you have calculated. For now I have kept it very simple. And after that, since we have used all these strategy, I would want to have a strategy manager at the end. Now, you would be thinking, what is the use of strategy manager? So basically, inside this strategy manager, will define what is the type of strategy that we want to pass whenever a main class calls the strategy. So we'll have basically the driver allocation strategy, then we'll have the pricing strategy. We'll define the constructor for both of these. And after this, I would want to just set and the allocation for all of them, right? So let me do set driver allocation strategy. Basically I would want to sorry. Okay, this public double gate driver list of location pickup. So here I'll just return the allocation strategy that we'll be using, and after that we'll allocate the drivers and the pickup location that we have defined. Okay, why is it complaining? Let me import the class. So after this, we'll allocate the driver based on the and after this simply we'll calculate price again for, and here I don't want to send the driver. I'll have the pickup location. Similarly, I'll have drop location, and I'll have the base price, and here I'll have this. So let me go inside this. Okay, this sounds good to me. For now I'll have like this. Okay, coming back to the strategy manager. Okay, now this sounds good to me. We have defined our strategy manager as well, so our strategy part is also done. Now finally we have to go and create the manager class. Okay, so I'll define a manager, And inside manager, our first manager is going to be rider manager. Okay, now what does a rider manager is going to contain? So basically in rider manager we'll be having a map of all the riders. So let's say we have riders map, import the class, and once we have defined the rider, we'll have public rider, get rider, string id, return rider dot get id. Okay, I think this should be okay for rider manager. And similarly we'll go and define the driver manager. Now similarly, since driver manager is gonna manage all the driver that the system is gonna pass, so first thing is, again, we'll be having a private map of string and driver with drivers and new hash map. Import the class, import this. After that we would want to add the driver, so we'll driver.put. okay, this sounds good. Now we would want to update the availability of driver, right? So what we can do is we'll just go and update driver availability, and here we'll just pass driver id and boolean is available. And after that, not just get driver id, but I would want to just check if the drivers dot contains key driver id. Then I would want to get the driver and set its availability, or set available dot is available. Now why, if I go inside the driver class is available, yeah, we are passing is available here, so that shouldn't be a problem. But yeah, we have to define one. Okay, now this sounds good to me. We have updated the availability of our driver class in the driver manager as well. Finally, the third manager that we are going to create is the trip manager class. So inside the trip manager, what all parameters and attributes we want to pass, because this is going to be the main component of our system, right? So first thing would be, definitely we want to define active trips. So similarly we'll define a map of string with the trip, and we'll define this as active trips. Okay, let's go and copy, import the trip and import the map for this. After that, I would want to have the driver allocation strategy. I would also want to have the pricing strategy. And once we have this, I would want to have constructor of all three of this. For active trips, actually I don't want to pass it over here, and rather I would want to create a new hash map. Okay, so here we have created the new hash map. After that, the first method that we are going to create for this, which is the most important one, is we want to create trip, wherein we want to pass trip id. We would want to have rider, we would want to have list of drivers, or maybe let me call this as available drivers we would want to have drop off location. Okay, so okay, all these methods are imported, and inside that method, what should be the logic, do you think? So first we want to allocate the driver using our strategy manager, right? So we'll get a driver based, we'll have assigned driver based on our allocation strategy. So here we'll call allocate driver method, we'll pass the available drivers, and we'll get rider dot get location. So this will give me the assigned driver. We'll check if assigned driver equals null. At that point of time, I would go and simply tell the system that there's no driver available. Okay, oops, sorry, and I'll simply return null. However, if I have assigned driver, at that point of time, I would want to create a new trip. So in this new trip, I would pass my trip ID, the rider details, assigned rider, and the location of driver, and finally the drop location. So this will give me a new trip. After that, at the same time, I would want to add this trip into my active trips that we have defined earlier. Now once we have defined active trips, let's tell the system that the trip is started with driver, and here I would pass assigned driver, and then for rider name. Okay, and here also let me get the name just to make things simple. Once this is done, and the next step would be definitely to calculate the price. Now whenever you want to calculate the price, at the same time we have to use the pricing strategy, right? So we'll use the pricing strategy, and here I would want to get the new trip pickup location, and at the same time I would want to get new trip drop off location. So using this two, and let me pass the base price as 50 for now, because we haven't defined any logic really over there, right? To keep the thing simpler, we'll get the calculated price over here, and at the same time I would want to show the system that estimated price would be the calculated price. And once this is done, I would want the system to return a new trip that we have created. So this way we have created a trip, right? Now let's go to the main section and see what all components we have defined already and what other things we have to take care of. So first let's import all the classes. So we have drivers now. We have to import the list. We have to import the locations. Let's import rider as well. So we have all these values. And why is it saying location boolean? Oh, wait. It would be first true. So we have location, then is available, and then rating. Okay. So we would have location is available, and then rating is 4.5. Let's remove this. Okay, and similarly we'll have location is available, and here 4.7. So this will be the driver for us. We have added the list of driver in the available driver section. After that we have defined riders. Once we have defined riders, we would want to have the location strategy defined, right? So for this, our location strategy would be let's say for nearest driver, and our pricing strategy would be for now fixed pricing. Once we have defined our location strategy and pricing strategy, we would want to have a trip manager, right? So for our trip manager, let's new trip manager with allocation strategy and pricing strategy. We have defined trip manager now, and at the same time we would want to have a drop off location. So I would want to give a drop off location as something like this, wherein we would want to have 56.11 and let's say 11.56. Okay, sounds good. So we have defined the location now. Now let's create a trip. New trip. Wherein we have to provide the trip ID. After that, we want to give the rider details. Oh, rider details are already there. Rider details, then we want to give available drivers, and finally we want to give the drop location. Once we have all the values in the, why is it complaining, create constructor of the driver, it's driver, and then we are providing a list of driver. Let's go inside the trip. Oh, we don't want to create a trip like this, however we want to use the trip manager, and here we'll create a trip. Okay, sounds good. And once this is done, our trip manager will complete the trip. Now once the trip is completed, the trip manager will complete that particular trip. Now let's go and define the complete trip over here. So we'll come back to driver manager, and the function that we are going to define would again be public void complete trip, wherein we just want basically the trip ID. So trip ID, and inside this we'll just check whether the trip will be active trips dot get trip ID. Once we'll see that, we'll check if trip equals null. At that point of time, we'll just say trip not found and we'll return. But if we have the trip at that point of time, we'll go and do complete trip. And then once we go back, where's the trip manager? We'll call complete trip, and then we'll remove from the active trips, and we'll just tell that trip is completed. I think the system seems good now. Let's quickly, so we have the drivers, we have added the drivers in our available driver list, we have created a rider named Alex, we have defined our allocation strategy, we want the nearest driver to be available and with the fixed pricing. We have defined the trip manager, we have created a trip, and then once the trip is created, we are completing the trip for now, right? So let's go ahead and run this particular test. So now here you'll see the trip is started with driver Rocky for rider Alex. Estimated price is 50 because we have kept the 50 as the base price, and then once the trip is completed, it's returning trip is completed. So I know that it's a long video, but I think we have completed the entire low-level design of the car rental system. Let me know in comments if you want to extend this with any other logic. But that's all for now. Thank you.